This theorem, we're going to go over the derivative of the natural exponential function. So this is the derivative of e to the x with respect to x is equal to e to the x. So this is, first of all, we're going to talk about Euler's number, which is e, okay, which is roughly 2.718. This is an irrational number, same as pi. It goes on forever. And this limit here, that we're going to look at mostly here, when we take the limit of the function 1 plus n to the 1 over n power as n goes to 0, that's going to equal e, which is this 2.718. Okay, so let's look at this. Okay, so here you can see the function, okay, and if I take the limit of this as n goes to 0, okay, so this is the function, as n goes to 0, I can't do direct substitution, right? I can't just plug 0 in for that because you're going to get an undefined value there. But what I can do, I can take the limit. I can take x is approaching 0, and this would be coming from the right. You can see as it gets closer and closer to 1, you're getting this 2.718, which is e. Okay, so now we know where e is coming from. This is going to come into play quite a bit for this proof. So I want to go through the proof so you know a little bit more besides just memorizing this rule. You'll definitely want to memorize it, but this would be a proof that I would expect that you could reproduce as well. Okay, so we're going to start with the derivative of f of x equals the definition of the derivative, which is the limit of f of x plus delta x minus f of x all over delta x as delta x goes to 0. So we pretty much use this definition of the derivative to prove most derivative rules. Notice that f of x equals e to the x, so f of x plus delta x would equal e to the x plus delta x. Now through substitution, right here, f of x plus delta x becomes e to the x plus delta x. And f of x becomes e to the x. So the first step here, I think that's pretty straightforward, pretty easy for most of us, right? Step 2, we're going to do some factoring here. So let's look at this over here. We've got e to the x plus delta x. Okay? So remember the rule here, when multiplying like bases, you add the exponents. So this is the same thing here. All right? This part here. Right? So then I can rewrite that whole numerator as e to the x delta x minus e to the x, and then factor out e to the x, which would leave me with e to the delta x minus 1. That's how I'm getting this step here. So hopefully you can see step 2. Step 3, I'm just factoring e to the x out in front of the limit since delta x is approaching 0, and this is just e to the x. No matter what delta x is doing, it's not going to change. It's not going to impact e to the x. Hopefully you can see step 3. Now for step 4, this is where it gets a little tricky. Let's look at this e to delta x minus 1. It says we're going to do this change of variable. We're going to let n equal e to the delta x minus 1, and then we're going to solve for delta x. So we're going to rewrite this equation and solve for delta x. So to do that, I could add 1 to both sides, right? And then I could take the natural log of both sides, okay, and then I would have the natural log of n plus 1 equals delta x. Now, notice, since this limit, delta x is going to 0, for this particular function, as delta x goes to 0, then n must also go to 0. Okay, because if delta x equals 0, then if n goes, delta x goes, then n has to be 0, because the natural log of 1 is 0. Okay, so notice the limit so this is implied here that if delta x goes to 0, then n must go to 0. So this next step, I'm going to call this n. Okay, I'm going to replace delta x with this part here. So this was delta x. Now it becomes the natural log of n plus 1, and then then n is going to approach 0. So there is step 4. A little tricky, but hopefully you can see it. Step 5 is not too big of a deal. What I'm going to do, I'm going to multiply the numerator and the denominator by this 1 over n. Okay, and then the numerator, when you multiply 1 over n times n, that's just going to become 1. And then 1 over n times the natural log of n to n plus 1. Here I could use the power rule for exponents, and I can put this 1 over n, write that as an exponent. Okay, step 7. So now what I did, I factored out this 1 over the natural log of all of this. So this limit of 1 over n, so the limit of 1 plus n to the 1 over n power as n goes to infinity. I wrote it that way. Well, notice right here, the limit of 1 over n to the 1 over n power as n goes to infinity, that equals e. So I can replace all of this with e. So I can replace all of that. So all of this right here becomes e. And then step 8, e to the x times 1 over the natural log of e. Well, the natural log of e is 1, which equals e to the x.